Hello Algebra 2 students, welcome to part 1 of section 10-4 inverses of trigonometric functions. In this lesson you're going to learn how to evaluate inverse trigonometric functions and how to use the inverse trigonometric function to solve real world problems. To understand the main idea of the inverse trigonometric function, take this famous example: sine angle 30 equals what? Guys, everybody knows that sine 30 equals half. Let's hide this angle and consider this angle is theta or x or any unknown. Now I can ask you the question in the opposite way. What angle its sine function is equal to half? And the answer, of course, is 30 degrees. Theta equals 30 degrees. This is the inverse of the trigonometric function sine. We read it inverse sine. Whenever you see this -1 on the top, this is not power -1. This is the inverse sine or the arc sine of the ratio half. What angle its sine ratio is equal to half? The answer is 30 degrees. We read this arc sine, arc cosine, and arc tan, or simply you can read it inverse sine, inverse cosine, and inverse tan. Guys, remember that all coterminal angles have the same trigonometric ratios. So not only the angle 30 has a sine ratio of half, but all coterminal angles with 30 degrees. To include those angles, you need to convert this angle from degrees into radians. This is gonna be pi over 6. So in order to include all angles, their sine ratio equals half. So in general, the arc sine of half might be the angle 30 or pi over 6 and all coterminal angles with this. How do I include the coterminal angles? By adding or subtracting any number of complete rounds. Guys, you know the complete round in radians is 2 pi times n. N is any integer number. You can add 1 round, 2 round, 3 rounds, any number of rounds. In example number 1, we need to find all possible values of the inverse cosine square root of 3 over 2. As you have seen, guys, in the previous slide, that there are many angles. Their cosine ratio is equal to square root of 3 over 2 in different quadrants, and also the coterminal angles. So how do I find all possible values of arc cosine square root of 3 over 2? First of all, you need to start with this value. This value is positive value. Square root of 3 over 2 is positive, and the cosine function is positive only in quadrant 1 and quadrant 4. Guys, in quadrant 1 and in quadrant 4, the sine ratio is positive because cosine ratio represents the x coordinate, and the x is positive in quadrant 1 and quadrant 4. So we need to find all possible solutions in quadrant 1 and in quadrant 4. In quadrant 1, guys, what angle theta its cosine ratio is equal to square root of 3 over 2? It's 30 degrees. So if the answer is in quadrant 1, theta gonna be 30 degrees and all coterminal angles with 30 degrees. So I can add any number of complete rounds to the 30 degrees. So in general, the arc cosine or the inverse cosine of square root of 3 over 2 is equal to, don't forget to convert this angle from degrees to radians. This is going to be pi over 6. So guys, it's pi over 6 plus 2 pi n. Anytime you want to include coterminal angles, you add 2 pi n. 2 pi is 1 complete round times n, any number of complete rounds. We need to study the situation in quadrant 4. In quadrant 4, we know the terminal side and we know the angle is going to be 30 degrees. But the angle, guys, is measured from the initial side at the positive direction of x-axis. So we're going to start rotation from here until we reach the terminal side. So how do I find the measure of all this angle? It's almost one complete round minus 30 degrees. So in this situation, theta equals 360 minus 30 is equal to 330 degrees. In order to convert this from degrees to radians, you need to multiply times pi over 180. It's going to be 11 pi over 6. So this angle is 11 pi over 6 radians. And now what are the coterminal angles with this angle? So the possible answers of inverse cosine square root of 3 over 2 is equal to the angle 11 pi over 6 plus 2 pi n. Okay guys, so this is all possible values of the inverse cosine square root of 3 over 2. Guys, because more than one value of theta, more than one measure of theta, as you have seen in example number 1, produces the same trigonometric function, it's very necessary and very useful to restrict or limit the domain of each trigonometric function. If we can limit the domain, we will get less number of possibilities and less number of answers. The sine function is in the restricted domain defined when the angle theta is greater than or equal negative pi over 2 or negative 90. This is equivalent to negative 90 and less than 90. To understand that, guys, when you talk about the sine ratio, you're talking about the y-coordinate, and the y-coordinate, the maximum y-coordinate occurs at this point. The angle theta is 90 degrees, it's in quadrant 1, or the minimum angle theta occurs here and the angle is opposite way, it's negative 90. This is why the domain of theta is negative pi over 2 and less than pi over 2. So from negative 90 to 90, this is the domain of theta. What about the range of the trigonometric ratio sine theta? Guys, remember the coordinates of this point is 0, 1. And the coordinate of this point is 0, negative 1. So the trigonometric ratio sine is defined between negative 1 and 1. So the range also is very important. So the range of sine is negative 1 to 1, because sometimes you're given a trigonometric ratio outside this range and the answer is undefined. For example, if I give you a sine theta equals 2 or 3, it's undefined because the range of the trigonometric ratio sine is negative 1 to 1. This is the minimum a trigonometric function sine, and this is the maximum trigonometric function of sine. So guys, how do I know whether we're talking about the restricted domain? If you're talking about the restricted domain, so you will find the first letter of sine is capital, the first letter of cosine is capital, and the first letter of tan is capital. Guys, we don't write sine, cosine, tan in this way. We just write them in small letters. But to define the restricted domain, to pay the attention that we are talking about the restricted domain, we copy the first letter is capital, so you know that we're talking about the restricted domain. So sine theta is defined only in quadrant 1 and in quadrant 4. You need to memorize these, guys. Same like the tan theta. Tan theta is also defined in quadrant 1 and in quadrant 4. And the range of theta, the domain of theta, is from negative pi over 2 and less than pi over 2. The cosine function, when you talk about the cosine function, you're talking about the x-coordinate. And the x-coordinate vary from this point to this point. So guys, this point is 1, 0. And the angle measure is 0 degrees. This point is negative 1 and 0, negative 1 and 0. And the angle measure here, it's pi over 180 because it's half round. So the cosine ratio is defined in quadrant 1 and in quadrant 2 only. cosine ratio in the restricted domain is defined in quadrant 1 and quadrant 2, and the range of the cosine trigonometric function is also negative 1 to 1. The minimum cosine value is negative 1 and the maximum cosine value is 1, so any value outside this range, it's undefined. Guys, now we're ready to study example number 2. What is the difference between example number 2 and example number 1? In example number 1, we have found all possible values of inverse trigonometric function, and as you seen, guys, there were many values plus the coterminal angles. But now, guys, we're doing what? We're evaluating each inverse trigonometric function and we giving exact answer in a restricted domain. How do I know this problem in the restricted domain? Look at the capital letter of cosine and the capital letter of the start of sine. So definitely we're talking about the restricted domain. Guys, we need to figure out the arc cosine of negative square root of 3 over 2. First of all, remember that cosine trigonometric function in the restricted domain is only defined in quadrant 1 and in quadrant 2. According to the restricted domain of cosine, it's only defined in quadrant 1 and quadrant 2. Guys, notice this value is negative, and cosine is negative in quadrant 2. It is not negative in quadrant 1. In quadrant 1, the cosine is positive. So guys, our concern is to find the angle theta in quadrant 2. So we have a specific particular answer this time, guys. Now, what angle? It's cosine equal square root of 3 over 2. You have studied this before many times, and you know that the angle is 30 degrees. But our angle is in quadrant 2. So this is the reference angle, 30 degrees. This is the reference angle, guys. Where's our angle? Our angle is always measured starting from the positive direction of x-axis, and the rotation is counterclockwise. So how do I find the measure of this angle? This angle is 180 minus 30. So my theta equals 180 minus 30. Because my angle is in quadrant 2, the only option is in quadrant 2. The cosine ratio is negative in quadrant 2, and basically the cosine ratio is defined in quadrant 1 and quadrant 2, but we choose quadrant 2 because it's negative. 180 minus 30, guys, it's 150 degrees. 150 degrees. In radians, this is going to be 5 pi over 6. 5 pi over 6. Guys, this time no need to add the coterminal angles because we're trying to find the exact trigonometric inverse trigonometric function, and the answer is 150 degrees or 5 pi over 6. It's restricted domain. Another example. Find the arc sine of 3 over 2. Guys, before you proceed and graph your unit circle and study the arc sine is defined in what quadrant, just pay attention to this value. This value is 3 over 2. 3 over 2, it means 1.5. Guys, the sine ratio range, do you remember? The sine ratio range is from negative 1 to 1. So this value is outside the range of the sine function. So the answer is the inverse sine negative 1, the inverse sine of 3 over 2 is undefined. It's undefined. There is no angle. Its sine ratio is equal to 3 over 2 because it's outside the range. See you in the next part of this section.